Welcome to day 15. Your homework will be to do the next 3 from the 2021 exam in your white packet. Make sure to be doing that on a separate sheet of paper. Question 1 was a calculator question. So we wanted to approximate f prime of 2.25. That's between two data values in our table. So all you're going to do is use the ones on either side, do a change in y over change in x. We get 8. We needed to put correct units. The f of r was milligrams per square centimeter. Because we divided by another independent variable, it's going to be per an additional centimeter. So milligrams per centimeter squared per centimeter. And what this is telling us is it's just the rate of change of our density. So it's the rate of change of the density at 2.25 centimeters from wherever our center is. All right, we want to use a right-hand Riemann sum. Notice we have an extra r that is in there. So I put my 2 pi out front. We want to use 4 subintervals. So here's our first subinterval, second, third, and fourth. So these spots here are representing the r portion of it because we're using the right-hand reference point. And then the 1 is the gap between our r's. So 0 to 1 is 1, 1 to 2 is 1, 2 to 2.5 is 0.5, and then 2.5 to 4 is 1.5. And then the other part is the height at the right-hand endpoint. So 2 is the height of our rectangle for the first interval, then the 6, then the 10, then the 18. You can either do it in terms of pi, or you can put the pi in and round it to 3 decimal places. And it was a mass, so they said our units there was milligrams. We want to know if we have an over or an under estimate. Well, notice that we are increasing. And anytime you are increasing, so I showed an increasing concave down. I could also show it with an increasing concave up. But anytime you are increasing, if you have a right-hand Riemann sum, it is an over estimate. And the reason being because f of r is increasing. Concavity would matter if we were doing a trapezoidal rule. So we want g of k. So that means take your g of r and replace all the r's with k. That's what we have here. We want that to be equal to the average value of g to r on 1 to 4. So average value, we want it to equal 1 over b minus a. So 1 over 4 minus 1 gives us the 1/3 out front. We got integral from 1 to 4, and then we've got our g of r. From there, you can graph both sides, because the right is just going to be a constant. And then the left, graph it, but put x in where k is, see where they intersect. Now, they might intersect multiple places. We got to make sure we find the intersection on 1 to 4 and just round it to 3 places. Question 2 is another calculator question. So we want to do speed. Speed is the square root of the x derivative squared plus the y derivative squared, and just replace t with the t that they wanted. Well, they gave us the velocity vector, so that was already our x and y derivatives. So just square them, add them, put the 1.2 in for t, and put it under a square root. Now, make sure you are in radian mode. So that's the first part of part A. Remember to always reread your parts when you think you're done to make sure you've answered everything, because this has multiple things they want. They now want us to find the acceleration vector at 1.2. So we're going to have to take the derivative of our velocity vector. In the first part, the x part, we have a product rule. So derivative of t minus 1 is 1 times the regular e to the t squared plus the regular t minus 1. When we do derivative of e to the t squared, e's derivative is e to the stuff times derivative of stuff. So we have e to the t squared times 2t. For the other part, we've got a chain rule. Derivative of sine is cos. Keep the inside the same, then multiply by the derivative of the inside. So bring your power out front. Power goes down 1, so we're raised to the 0.25 now. From there, just sub 1.2 in, round it to 3 places. Total distance traveled is same as saying the arc length of the path. So if arc length for parametric is just integral of that same speed setup, but without the 1.2 subbed in for t, so you get 1.010. For part C, we want furthest left. So we want to think of the x of t, and we want to know when x of t has a minimum. That would be furthest left. So take your x prime of t, which is the x part of your velocity, set it equal to 0. Now we wanted t equals 0, so I probably should have put a 0 on here, and then we're just working to the right of 0. But so 1 is a critical value. Using your calculator, you find it's a minus plus. So we've got a minimum for t equals 1 since x prime of t switches from negative to positive. And then we want to do an accumulation function because we wanted the coordinates of that. So do an accumulation function for the x. We knew at t equals 0, we had a x value of -2, and then do the accumulation from 0 to that 1 that we just found, which was when we were going to have the minimum of our velocity x part. And then do the y coordinate that we knew at time 0 and do the same thing for the y's. And then we just want to round that to 3 places. For the second part of question C, the reason it is never furthest to the right is there is never a relative maximum. Our second interval there, x prime is always positive. So as t continues to increase, we're just moving further right, 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 so there is no furthest to the right. And part 3, this is now a no calculator question. So we want to find the area of the region. So if you're in terms of x's, that's integral of top minus bottom. If you're in terms of y, that's integral of right minus left. So we're just doing our integral of, they told us c was 6, so of 6x squared of 4 minus x squared. Now we had to figure out when it was going to be equal to 0. The 0 part was easy. So this part here gave us x equals 0. That caused it to be 0. Now for that part there, x equals 2, because if we look at our graph, it's going to the right, so it's got to be some positive x. So x equals 2 would make that part be 0. So this is really 2 comma something, and this is 0 comma 0. That's why we got our bounds. From there, we had to do a little u substitution. With your du, we wanted 6x, so we'd have to multiply both sides by -3. I chose to change my bounds. They became 4 and 0. It is okay that they are opposites, or that the bigger one's on bottom. Whatever 0 gives you has to go on the bottom. Whatever 2 gave you has to go on top. Now, if I wanted to, I could have now then flipped my bounds and made it a +3 out front. I chose to not because we weren't finding the area by hand. It'll take care of itself with the signs and everything in the integral. And we go through it, we eventually get that area is 16. So in B, they gave us our derivative dy dx. We know our radius of the largest cross section is just 1.2 inches. So what we can do is we can put 1.2 in for that value of y, because because it's revolved around the x-axis, the radius is going to look like that. So really the radius is the same as the y value in our function. So I subbed 1.2 in for the y, and now I've got c in terms of x. Well, when we are at the largest radius, we should have a turning point on our graph, meaning the derivative should equal to 0. So I made dy dx equals 0, and then we can take this expression for c and fill it in. And now what we have is an equation that only has x's. So the square root in the denominator multiplies the other square root in the denominator. So we now have this. We could pull a 2 out of the numerator and then set that numerator equal to 0, because a fraction is 0 when just the numerator equals 0. So now we've got a factor of 2 minus x squared. That'll give us plus and minus radical 2. Well, our graph was all to the right of the y-axis. We would want the positive radical 2. Then go back to your c, sub in the radical 2, and SEE, see what it gives you for c. Now, because this is we're on part B. Because this is a no calculator, we wanted to find the value of c. You could have, if you wanted, just circled this as your answer. I showed the simplified form in case you simplified it, but what I have circled there would be a full credit answer as well, because it's c equals a number. So now we're working with volume. Our region was completely resting against the x-axis. We want to think disks, which is in the form pi times your radius squared. Our radius is our radius is top minus bottom because it's a vertical line, so it's function minus 0. So we just have the function there then. And then take your setup, set it equal to 2 pi, so divide the pi's out of there. I chose to just square everything and pull the c out front. So I just carried the c squared out front, do your antiderivative, sub stuff in, divide over, and then take the square root. Now, it was really your choice how much you wanted to simplify that. You could have, say, like in this section here, said that c was equal to square root of 2 over 160 over, and you didn't even need the 160s. You could have done the non-simplified part from the previous step, 32 over 3 minus 32 over 5. And we would want the positive square root for c, because they told us c was positive in the question. Okay, and then this is much more simplified, but anything where you got c by itself would be a full credit answer.